All right. Hey, biology. I'm used to saying AP biology. Biology. Hope you're doing well when you watch this. So this is about the Finch lab. We just completed it. All right. So this Finch lab was based upon the grant's work with finches on Daphne major. And so what they saw was that there was this huge drought, and you can see that the survivors, the non-survivors versus the survivors, well, you see that there's a directional selection here. That the larger the beak, the greater the fitness, which means the ability to survive and reproduce. And so we saw this in our simulation lab, right? So I want to talk to you about the graph, right? So condition A was both food sources are good to go, everything is great. Condition B is the drought, right? So only large seeds were available. And condition C was after the monsoon, and so there's a ton of small seeds, okay? A lot of different ways you can graph this, but just for practice, I'm gonna ask you to graph the averages, right? And so since we're dealing with distinct categories, you should do a bar graph. Line is usually used with time or continuous variables, and scatter plots are used with continuous variables. So a bar graph or a histogram would work well here. And I want to talk to you about standard error of the mean, SEM. Okay, and SEM is probably a little beyond the scope of this course, but basically standard error of the mean is a statistical measure that tells you how much variability there is in a sample mean compared to the true population mean. So if you just take a random sample, how much variability would there be? So the larger the sample size, the smaller the standard error, because more data gives you more accurate. That's why we did lots of data. Data is a good thing. More data points is a good thing. And the greater your sample variability, the greater the difference is, the larger the standard error, okay? And so what usually this shows is that it shows, why would we use standard error in the mean? It shows how precise the mean is. So a smaller SEM is more confidence in the mean average, the more confidence we have in our data. Okay, and so for one thing for sure, like if you have a bar graph, well, that's a circle, a parabola or something. If you have a graph, okay, and you have like a bar graph here and a bar graph here, and like the standard error, you kind of graph like this, right? And so do you see how they overlap? Well, if they overlap, we would say that is not significant, right? Because it's the same data. Okay, but if you have another pair of data over here, and usually, and this is more AP land, but usually they were like, that is statistically significant because the error bars do not overlap. There is significance in that data. And so let me just go through an example with you. Let's say, and I'm not going to show you how, again, you want to do a bar graph, and we're graphing the averages with a plus or minus SEM. And so the SEM is this line right here. And so I'm gonna, again, you do want a key, right? And so let me just give you an example here. Let's say condition A was, let's just say the average was 12 for small, and large was 6, and then the SEM was 1 for that, and 0.5 for that. Okay, so again, I'm just kind of giving you an example of this one, changing up the numbers because I didn't want to give you an exact answer here. And so here's going to be our graph, right? And so I'm definitely going to use a key. So here is, we're just going to say condition A right here, condition A. And then we're going to have a key over here. And maybe we do lines for small beak. Okay. And so that's going to be, 5, 10, 12. Right? Again, make sure the spacing is nice here. And then large was 6, so 6 is about right here. And you can see that the standard error was plus and minus 1. So you go up to 13 and down to 11. So you go up to 13, down to 11, and you graph. And large was 0.6, so if that's 6, and this is 5, sorry, 5 should be right there. Let's erase. I should have used I forgot they have graph paper in this notability program. That would have been smart, Mr. Harkala. All right, but 0.5 is very, very tiny, right? And then let's just color in large. Well, actually, probably shouldn't color it in with the same color because that would be hard to see, but we can color it in with like a lighter color, like maybe just like green or something. And we can make this one purple. Okay, so purple is small, green is large, right? The x-axis is conditions, and the y-axis is what? What do you think a good label for the y-axis would be? And a title would be nice, but it's not the biggest deal in the world. Okay, and so that is an example of how to graph this. So what I'm looking for, again, you got to graph all the averages, right, with the corresponding correct conditions, and then the SEMs as well. Want to see a good, clean, crisp graph and the back of the lab paper, back of the paper. Okay? All right, hope this was helpful, guys. Much love in Christ. See you.